Okay, welcome to the next video for the study guide. These are the AP style questions from College Board, and they are the just the assignment questions. So some of these you may have already seen before, but we're going to redo them anyway. So here, the binomial theorem can be used to expand an expression of the form a plus b to the nth power. Which of the following is equivalent to a plus 3y to the fifth? And again, I talked about this in class. If you do this, where you just move the fifth in, this a hurts my soul. I should not see anybody put a on this question. Please, it will. I'll have a stroke. It's devastating. Okay, so let's see what we got here. I'm going to use a bit of a highlighter here, just to keep track of things. So, x. There we go. So let's see what's different from all these. Well, maybe I don't need a highlighter. So these coefficients are 1, 1, 1, 1, 1. So if this is to the fifth power, the coefficients need to be the fifth row of Pascal's triangle. And the fifth row of Pascal's triangle is 1, 5, 10, 10, 5, 1, I think. So this is 1, 1, 1, 1, so it can't be that one. This says 1, 4, 6, 6, 4. Nope, can't be that one. This says 1, 5, 10, 10, 5, 1. So it has to be D. D is the only one it can be because the coefficients are correct. Okay, number 2. The polynomial function p is given by p of x equals this. Which of the following expressions is this? So we're going to expand this one as well. So let's see what's different on these. Here, so we can't go by the coefficients because they've simplified them all. Here, they hadn't simplified them. So they didn't do 3 squared. That would be 90 if they had simplified, but they simplified down here. So let's expand this one out. So this is 1, 4, 6. This is the fourth row. So 1, 4, 6, 4, 1. So this would be x to the fourth, so 1x to the fourth, plus 4x to the third, 2 to the first, plus 6x squared, 2 squared, plus 4x to the first, 2 to the third, plus 1, x to the 0th, 2 to the fourth. So x to the fourth is my first term, so it can't be this guy. My next term should be 8x to the third. 2 times 4 is 8, so that one's fine. This one's not good. This one's not good. So that only leaves c. If I finish squaring them out, 2 squared is 4 times 6 is 24x squared. 2 to the third is 8. 8 times 4 is 32. And then 2 to the fourth is 16. There we go. The function f is given by f of x equals x plus 3 to the fourth. When f is rewritten in the form of x to the fourth, a to the third, b, yada, yada, yada. Which of the following values is the greatest? So we need to expand it and simplify. So x to the fourth, it's supposed to be 1x to the fourth, 3 to the 0th, plus, this is the fourth row, so we're going to use 1, 4, 6, 4, 1 again. So this would be 4x to the third times 3 plus 6x squared times 3 squared plus 4x to the first, 3 to the third, plus 3 to the fourth. 1 times 3 to the fourth. So x to the fourth plus 12x to the third. So a is 12. 3 squared is 9. 9 times 6 is 54. So it's 54x squared. So b equals 54. So it can't be a, because 54 is bigger than 12. 3 to the third is 9. Not 9. 3 to the third is 27. 27 times 4 is 108. So this will be plus 108x. So it can't be b because 108 is bigger. So c is equal to 108. And then finally, d, 3 to the fourth is 81. So d is equal to 81. So it must be c. The graph of which of the following functions in the xy plane has at least one intercept, at least one hole, and at least one vertical asymptote and a horizontal asymptote. So it needs one of just about everything. Okay, so let's we're going to have to factor each of these. So let's start factoring. So x minus 2, so this is going to be, we're going to look at a first. X minus, that's difference of squares, difference of two squares. So this is going to be x plus 4 times x minus 4. All over, what two numbers multiply, so another quadratic, what two numbers multiply to be negative 6, but add up to be negative 1? So that's going to be x minus 3 times x plus 2. Okay, so we need at least one x-intercept. I have two x-intercepts, so that's fine. At least one hole. Nothing cancels out. So there is no hole here. Nothing cancels out, so it can't be A. Let's try B. B is the same difference of two squares, so this will be x plus 4 times x minus 4. What two numbers multiply to be negative 30 but add to be negative 1? So that's going to be x minus 6 times x plus 5. Again, nothing cancels out, so there is no hole for this equation because the 4, nothing cancels out. So it can't be B. Wrong color. It can't be B. See? So this is difference of two squares again. This time it's going to be x minus 2 times x plus 2 all over. What two number? Oh, this is the same as the one above, and this, so this is going to be x minus 6 times x plus 5. Again, there is no hole here. Nothing cancels out. I hope I'm doing these right. So hopefully this last one will be fine. Okay. So here we have D is our last option. So difference of two squares, x minus 2 times x plus 2 over. This one is the same as this one on top here. So this is x minus 3 times x plus 2. Okay, so we have a hole. There we go. There's our hole. Our hole at x equals negative 2. I have a vertical asymptote. The vertical asymptote at x equals positive 3, so that's my vertical asymptote. And then I have a, so one hole, one vertical asymptote, yep. One x-intercept, so my x-intercept, this guy's all by itself, so I should have an x-intercept at x equals 2. So, and then do I have a horizontal asymptote? Well, this is degree 2 over degree 2. There's a horizontal asymptote of leading coefficients. So it must be D. Must be D. Okay, I'll see you guys in the next video.